All right, so we left off here looking at this picture, and I'm going to copy it and bring it into our notes so we can get kind of a sense of it. There we go. Okay, so what in the world is going on here? This is the SAT problem still. The mean is 1,000, see? And the standard deviation is 200. Now this big pink, it's actually a purple curve. The purple curve has a standard deviation of 200. This blue curve right here has a standard deviation of 200 divided by the square root of 30, which I don't know if we did over here. We didn't. We did it right here, about 36 and a half, okay? Much, much smaller. And this is what happens, right? So when you're looking at 1, n equals 1, that's the purple. If you're looking at n equals 30, that's the blue. I mean, notice how completely different these curves are from each other. Okay. Now, what happens to the tail probabilities? All right, so what I'm talking about here is look at these tails over here. This is for 1 n equals 1. That area right there. And then how big is that same region from 800 over to the left for the purple curve versus for the blue curve? Well, you can see for the purple curve, it's going to be, substantial. But for the blue curve, it's like unreadable. It's so small. And that doesn't change even if I look over here. Now, how would you find the area? Well, let me use Excel. I'm going to bring it over here so you can see it. All right, so to find the area under a curve, we learned in chapter 7, that's equal to norm, dist. And, of course, you can do this on a calculator too. It's slightly different, but our value is 800. Our mean is 1,000. Our standard deviation is 200, and we want true. Okay, so that's for the real purple curve right here. So that region's 0.158655. Let me put that in there. Oh, there it is. I remember. 0.1586. Actually, I think it's 87 if you round it. Okay, that's that area right there. All right, now let's go find it for the other curve. So I'm going to drag this because most of it's going to stay the same. But instead of 200, it's going to be 200, 200 divided by the square root of n, which was 30 for our case. And look at that. Now think about what that is for a second. Let me type it out. 2.16. Okay, so it is 0.023, 1, 2, 3, 4, 5, 6, 7. Yep, 7, and then a 2. You have to move the decimal place. Here, let me see. You have to move it 8 spaces to the left. It's scientific notation. So you got to go 1 space, 2 space, 3 spaces, right? 8 spaces, which means you'll have 7 zeros and then a 2, which is really tiny. Right? Really, really, really tiny. Well, that's because, look at this curve. There's like nothing under it. You've long passed 2 standard deviations away. 2 standard deviations away is like over here somewhere. So we're way past that. Let me copy. I don't know if this is going to show up very well. It doesn't usually like text boxes when I do that. Oh, there it is. That's okay. It gives you a sense. Okay. So what does that mean for us? It is much blank for a random group's average to be far away from the mean than for an individual. All right, so let's look here. This value, that's for the group. This value is for the individual. It is much harder for a group to have an average that's far away from the mean because people balance each other. In a random group, you're going to get highs and lows and they'll all average out. And it's much easier for a single person to be far away from the mean. You can have a person score really low on this test. Right, the average is 1,000 on this test. People are scoring 600 and 500. That's not hard for one person to do at random, but it's hard to get a group of 30 people to have an average that's that low, which means since it's harder to do, that means it's a much lower probability. Oopsie, I guess I have the word probability right there. Okay, so that's for tail probability. And then I'll be right back here for the next video to talk about what happens in the center portion. See you then.